So we're going to be reviewing for summative number 7, and we're going to start with the trig questions, the older concepts, simply because it's been a while since some of us took these trig questions. So I want to start with these. It's 2 trig sections plus 2 conics, the parabolas and the hyperbolas. This test, I'm a little worried on time, so we're going to talk about how we can save ourselves a little bit of time and energy on this test. So on the review page that you picked up yesterday, number 1, it's kind of in the middle of the page. I want you to solve this for all solutions, and it says you may need U substitution. I think on the directions for the test, we just wrote, you will need U substitution. So like there's no ifs, ands, or buts about it. However, you do have to isolate on this one before you do any solving. So this really says the sine of 3x. This reduces to negative square root of 3 over 2. So this is where you could use U substitution, where you replace this with the variable u, but then you got to come back and replace it again. We're on the review. Do you have a copy of that? So we just kind of cut out the middleman and we say, whatever this thing is, it either could be, and then we already know it's going to be 2 different things. So go check out your unit circle with me. Where is sine going to give you, where on the unit circle do you get a sine ratio for negative square root of 3 over 2? So that would be the pi over 3 family, right? So get the right quadrants. Me thinking 4 pi over 3. That would be a negative. And 5 pi over 3. So you guys did not have trouble with that. This is where the trouble occurred last time. Right now is where you put the plus 2 pi n down. You guys were putting plus 2 pi n in a weird spot in your work. It has to show up right now. Then you're going to come back through and you're going to say, okay, I'm going to reduce this angle. And instead of dividing by 3, we just hit every term by a multiply by 1/3. So I don't know why I wrote so far over. This becomes x equals 4 pi over 9 plus 2 pi n over 3. We're just increasing all the denominators by 3's, you know. And then this guy becomes x equals 5 pi over 9 plus 2 pi n over 3. Yeah, you can't read that, but you know what I mean. These are your answers, guys. This is not going to be the harder ones where you got to go back then and find all the solutions between 0 and 2 pi. That's more work, and we're not making you do that. So I think if everyone could just improve on when the plus 2 pi n shows up in their work, you'll see a lot better scores on this section. However, in the same section, you're going to see questions like this. And it'll say, use a Pythagorean trade. Now, I get it. There's a lot of things on your formula card that you could trade out. But if I tell you Pythagorean trade, I'm telling you to look at the Pythagorean trades, guys. And the one that we keep using over and over again for these questions is this guy. It's the cosine squared plus sine squared equals 1. So right here, one of these things is not like the other. Can you trade out sine squared for me? Yeah. Sine squared, if you rearrange this equation, you would just subtract the cosine squared over here. So I'm going to trade that for a 1 minus cosine squared. Now the rest of the equation can stay. And now we're all in terms of cosines and constants. Yes, because this one we're going to have to approach through factoring, which means it has to say equals 0. Everything has to be on one side. So I think it would be very smart if everybody moved everything to the left. So let's add cosine squared over. And then let's subtract a 1. I'm just going to sneak it over there. So watch your like terms here and be careful. This is 2 cosine squared minus cosine. And then there's a minus 1 that we moved over. Now, this is a factoring question. If you were having a tough time factoring this one, then think about his quadratic cousin. Just replace all the cosines with x's. I think we had to subtract it over. So the quadratic cousin here would be like 2x squared minus x minus 1. So if I asked you to factor this one, you know, obviously y'all could factor that one just fine. But the only thing that changes here is you got cosines instead of x's. So when I look at my leading term, I'm going to need 2 cosine times 1 cosine. And then for your ending terms, they got to multiply to negative 1. And if you kind of think ahead about how your arches have to work out, if you made this last one a negative 1, and this guy a positive 1, that would work out perfectly for the arches because you'll have -2 cosine plus 1 cosine. So we have it factored, and now we're going to set it equal to 0. So this guy gets set equal to 0, and this guy gets set equal to 0. With the, knowing that I'm trying to save a little bit of time, if this is not an area where you have concerns, I think you guys can solve this for cosine without showing any work. So this particular one, you would subtract 1 and divide by 2, right? Yeah, and you don't have to show me a two-step equation to do that. Y'all in PreCalc, you can do that. This guy, if you set it equal to 0 and solved, you'd be getting cosine equals 1. And they want all answers just between 0 and 2 pi, not inclusive on the 2 pi. So check, let's start with cosine -1/2. Where on your unit circle is cosine -1/2? 2 pi over 3, cool. And 4 pi over 3. And what about cosine equaling 1? Good. I like that Piper called that 0 and not 2 pi. Would I count it right if you said 2 pi? Because there's a non-inclusive bracket on 2 pi. Okay, so far so good? Well, I will say this. Comparing this to the original time we tested 5.3b, we didn't make it any harder. And one thing that we did that I think will help a lot of kids, we had the problems kind of embedded in the problem itself. Like it was a whole bunch of text and font all together. Like tangent of x times sine of x minus 2 tangent of x equals 0 is the, like all the words were in one line. It was just a lot to look at. So one thing I think we did better this time was we pulled the actual algebra statement out of the problem. So if you just know there's only so many things I'm going to ask you to do. Use substitution, and it'll just say like, use substitution. Trig a Pythagorean trade, and then there's probably going to be a lot of factoring on this section. So set it equal to 0 and factor. I did not see too much of the dreaded you guys trying to factor without setting it equal to 0. That's like the #1 boo-boo in math. And you guys didn't do that. So that made me very happy. This is another factoring one. Okay, most of you didn't do that. I'm going to give a little heads up here, guys. You're going to factor that one as well. If you don't mind, I'm going to skip that one. I can do it, but it'd be good for you to practice it. That's what I'm saying. All right, this one, again, I think you need to factor it. Yes, you should move things around on number 3. Good call. It's not quite in the right form, is it? Do you know what I mean by factor on number 4? It's not your typical, like, trinomial. Yeah, the factoring out kind of a thing. So take out a tangent term. And that would leave you with, oops, why am I moving x's instead of thetas? So tangent of theta times tangent of theta, and then you'll have a -1 right there when you factor out that tangent. So now, yes, this is factored. So if you set this equal to 0, and then you set this equal to 0, well, that first one's like ready to go. I'm just asking you, where does tangent come out to 0? And then, tangent's my arch nemesis, so I always like do a double check on my calculator. I'm pretty sure tangent at 0 is 0, but y'all, you got a calculator. Just type tan 0. It gives you 0. So there, mystery solved. I don't know why kids keep forgetting they have calculators. Yeah, you should have a calculator, that too. So tangent is 0 at 0 radians. Where else would tangent be 0 then? If it's 0 right here at this guy, it's also 0 over here. So at 0, at pi. All right, let's talk about this guy. Where is tangent 1? The pi over 4 family. Not just pi over 4. Where else? Oh, I want only positive 1 though. So 5 pi over 4. Very good. She got really happy on that list for a minute. Was rattling them all off. Okay, so yeah, this is a great moment in math where everything you know about a trig equation built, and there's its synthesis. All right, 5.5 is another section where we just tested it, but we're going to do a little better. I'm going to show you a secret to this question that I think is going to make everybody's life better. Now, one of the things Mrs. Hoffbauer, sweet lady that she did, is she filled out the whole triangle for you, so you don't even have to do Pythagorean Theorem. We were very worried about time on this test for you guys. We were trying to figure out, like, I know you guys can do Pythagorean Theorem. I don't need you to do Pythagorean Theorem, so I'm just going to give you the missing link. Yes?
I found one thing that I was having trouble. The arrow was just bothering the crap out of me.
Okay. She got a couple kids who said the same thing. They're like, what are they pointing at?
Yeah.
This triangle is angle alpha, is to land in the unit circle over here. So she did move the arrow a little bit, so hopefully it bothers you less. Don't overthink it. This is not meant to... I actually think this is one of the easiest questions on the test. But I'm going to show you the mistake that I saw from you guys, and I'm going to show you a way to eliminate that mistake. All right, Pythagorean Theorem, this guy's a 61, and this guy's a 20, I think, yeah. All right, so anywho, angle alpha, I'm going to call it A instead of alpha. Talking about this triangle, the sine ratio for that triangle, go back to old school sine ratio, that would be 60 over 61. The cosine ratio would be negative 11 over 61. And then this guy, this is beta or B, the sine ratio, go back to the old school ratio formula, is 20 over 29. And then the cosine of beta would be 21 over 29. So this next part, all I want you to do is copy the identity. Don't actually do math on this line. You're just copying it. Here you go, Piper. So sine of A minus B, that's sine, cosine, cosine, sine with a subtraction sign in the middle of it, but it's on the formula card if you forgot. So you're going to write sine A times cosine B minus cosine A times sine B. And here's how you're going to make everything better. Could you please put parentheses around sine of A, cosine of B, and cosine of A and sine of B? Once you write it like that, I guarantee no one's going to do that silly thing you did last time. Because last time what I got from kids was sine of 60 over 61. No, child. The sine of alpha is 60 over 61. So it is the sine function. You don't keep the sine function in your work. So the sine of A, or the sine of alpha, I'm going to replace this guy with a 60 over 61. And then the cosine of beta, right here, is 21 over 29. You got a subtraction sign right there. Cosine of alpha is this guy. So again, I'm going to replace that with the ratio negative 11 over 61. And then sine of beta is 20 over 29. And when you start writing that with parentheses, all of a sudden things become more clear in the brain. Type that baby in the calculator, okay? This is really gross, by the way. It's like an incredibly gross ratio because we got some pretty intense hypotenusae. Hypotenusae, I think I made that up. Hypotenuses. What if the plural was hypotenusae? It's not. It's hypotenuses. Yeah. Right? Like hippopotamus, hippopotami. It's not the same. Yeah, right? So 1480 over 1769. Yeah, I was totally gonna... No? You didn't get that?
I did.
Okay, did you lose that extra negative here? This is subtract negative. Did I lose a negative?
Nope.
Piper, what did you do?
Okay, for the first one, it's 60.
Oh, that too. So, and that would be the good news for Piper. Since she wrote out her math, I would just assume she had a mistype and not really ding her. Maybe at all. Who knows? Who knows? All right, so I don't know why we give you so much space on that problem, but that's all you needed to do. Okay, so it should be a nice, easy question. Please don't overthink it. All right, this next guy. You guys did a nice job of graphing the triangle for me. They said it's between pi over 2 and pi, so we're over here. That's straight. Now, be careful on this ratio. The tangent is negative 4 over 3 as a ratio. So the sides, this would have to be a 4 and this would have to be a 3. Which one's negative? The 3 is negative. Good, good. Watch your signs when you fill out the triangles. The hypotenuse would be a 5. Either Pythagorean Theorem or you just know a 3, 4, 5 when you see it. Okay, I want you to copy the trig trade for cosine of 2 pi. You got choices, child. You can use any of them that you want. There's 3 of them. Who's your favorite?
First.
I like the first one too. So it's cosine squared minus sine squared is the first one. If you like the other ones better, that's fine. So now, again, I think this will make a world of difference if you guys put parentheses around this. But the only thing you got to be careful about in using this identity is the squared. So when I go to write down the ratio for cosine, I have to remember to square it. And then same thing for the ratio for sine. So back to your triangle. The cosine ratio for this guy is -3/5. We're going to square that. And then the sine ratio would be 4/5, and we're going to square that. And we're going to subtract them. And babe, I just typed that right in the calculator. You think I'm going to do mental math on my test? You got your wires crossed, guys. I am not doing mental math at all anymore for the rest of the week. I'm done. That's not really true. You didn't square it. Well, square it. You should get -7/25. Yay. -7/25. You didn't get that? Did you lose a negative, child? Oh. Double squared. She fourthed. She fourthed it. Alright. I know this one says you may need to trade and use substitute. The test, it says you will trade and substitute. There. How blatant is that? So think about what section this is in, guys. This is section 5.5. It's all the double angle formulas. This is somebody. Who is it? It's cosine 2 theta. So swap it out. So now it says cosine 2 theta equals -√2/2, and this is where that use substitution stuff comes back. So you're going to see another one of these on your test here in this section, and we're going to kind of take a detour, but not really. We're going to just say 2 theta could be two different things. Where could we be looking if I'm looking for a cosine coming out to a -√2/2? Good. So 3π/4 and 5π/4. And right now is where you put the plus 2π in. So these weird use substitution questions, just let's do better at when the 2π n shows up. All right, but let's fix this because we got to reduce the angle. So hit everybody by a 1/2. Same thing as dividing by a 2. So this guy becomes, good, 3π/8 plus pi n, nice. And this guy becomes, very good, nice. And all I want is all solutions, which is the nice way, so there you go. So don't be shocked when you have to do that technique twice in your test. One in section 5.3 and another one in section 5.5. Okay. I can, yeah. Did yours not work out? Did you rearrange it a little bit? So you got, yeah, you got the -1 = 0. Okay, so it's a plus. Yes, it is. It is. Like I said, +1. So the leading term here, what times what will be 2 cosine squared? Well, that's going to have to be a 2 cosine and a 1 cosine. And then I'm thinking a -1 and a -1. Would that work? Because that'll be -2 cosine on the outside arch and -1 cosine on the inside arch, and that'll add up to -3 cosine on the middle. It's a little hard to look at cosines and think about them as x's. So if it bothers you, you could have rewritten it as 2x squared minus 3x plus 1 and gone through and factored it that way, and then came back and swapped out cosines. All right, so you got it from here, Taylor? You want me to look at it? Okay. Got it. Set them equal to 0. And this time they did want all solutions, so just list them out and then be lazy and put plus 2π n on all of them. I'm okay with that. All right. Was that all the trig? Did I get all of them? Yeah. All right. There's a little note here. Extra 5.3 or 5.5 practice. Remediation worksheet. You know that bin of remediation? If you're like, man, I stink at these. There's a whole pile of them with the answers on the back, okay? You could also go back to your old reviews, the old slides, the old homework that you totally did and you can do it again. All right, parabolas. I'm going to be honest. I think I'm more worried about parabolas than anything else.
Really?
Yeah.
I'm way more worried about this trig stuff.
Well, out of the conics. I
Oh.
think parabolas, ironically, I don't know, I think it's difficult because all the conics have so many similar things, and they're all just so very different. So, we have to also think about how fluent am I in this? Have I done my practice? Do I feel comfortable? What is the quickest way for me to get this question right? If I have to keep going back and using formulas every single time, does that slow me down too much? Am I going to run out of time? And the answer is yes, it will. So we got to think about being quick here. So if you could find worksheet 11, I would like to look at number 2 on worksheet 11. We're going to look at a couple things on worksheet 11 actually. And they're going to want me on the test, they're going to want me to not only graph the parabola, but like very specifically find stuff. So they're going to ask you for the vertex. They're going to ask you for the focus. They're going to ask you for the directrix. They're going to ask you for the axis of symmetry. So vertex, that's old school, man. Vertex is at -1, 2, yeah. So there's your H and K in case we need that later on. Did anyone notice something kind of weird about this formula though when I compare it to what's on my Pepto-Bismol pink sheet? It's backwards, and I think that's going to be a problem for your dyslexic teacher. So I'm going to go ahead and just do this, which was very dangerous because now I can't remember what it was. Was it x plus 1?
Yes.
Cool. So I don't like when my formulas don't look like my formulas. That really bothers me. So I rearranged it. The value in front of the x plus 1. What is that in regards to the formula? It's not p, it's 4p. So this number is 4p. So that means p is -1. The formula will say 4p is in front. Okay. So the formula for focus, and have you figured out what kind of parabola you're looking at? Are you looking at the right formula for parabola? If y is being squared, that means you have a horizontal parabola. So make sure you're looking at the sideways ones. The focus formula is h plus p, comma k. So for us, that would be -1 plus -1, comma 2. PreCalc, you're better than this. Give me the right ordered pair. It's at -2, 2. The directrix for this kind of parabola is at x equals h minus p. So for us, that would be x equals -1, I lost track of what I'm doing, minus -1, so plus 1 that'll become. So this is x equals 0. The axis of symmetry for this kind of parabola is going to be at y equals k. So for us, that would be y equals 2. And that's great, but I'm really not going to use any of that when I go to graph it. Okay? I'm going to plot my vertex, that I will do. I know it's horizontal. What's the significance for p, though? What does p mean for a parabola? This is where the conceptualizing is really going to help you. It's just the distance from the vertex to the focus or the vertex to the directrix. So for me, what I do is I say, okay, it's horizontal with a negative p-value, so it's going to open to the left. So your focus point is right here, 1 unit to the left of it. And your directrix line is 1 unit to the right of it. Now notice the things that I just graphed. I just graphed a directrix at x equals 0, and I used the wrong color. Thanks, Abruzzo. Try that again.
Do we have to have the directrix dotted?
It could be a line. It's fine. It is technically a line. I just don't like to graph it as a line because it confuses me. I'm very confused a lot. So this is x equals 0, and that green little star, is that at -2, 2, like I predicted through the formula? So there you go. Now the axis of symmetry is at y equals 2, which is right here, which goes straight through the vertex, through the middle of the parabola. And then when you go to graph the actual parabola, this is where you guys can do a little bit of cheating. Do you remember the shortcut? So if you don't remember the shortcut, you'd have to rearrange your equation for x. So you'd have to get x by itself. You'd have to multiply by a negative 1/4. Leave it in front of the, oops, that's y minus 2 squared. And then you'd have to subtract 1. And then you'd have to find an ordered pair, which, like, it's not the end of the world. It'll work. But the shortcut, Adam says, is take this number that's in front, this 4p number, cut it in half. So 2. Ignore the negative. So 2. And then from the focus, go that many units up and down for this kind. So from the focus, up 2 units and down 2 units. I promise it'll work, yes.
That's the only number of points we need to have problems.
Yeah. Vertex and a couple symmetrical points off to the sides of the vertex would be perfect. Okay? Now, if you don't like that or if you forget it, then you're going to have to resort to this method. And remember, you're plugging in numbers for y, which means you got to come out with, like, did you just draw a really nice one? Oh, that's beautiful. Mine doesn't look anything like that.
I have a question.
Yeah.
Out of curiosity.
Yeah.
Like make a parabola at a 45-degree
Oh.
angle.
Yeah? Not in the Cartesian coordinate plane, though. You'd have to be
I don't know what
using
that means.
XY coordinate plane.
Oh.
Yeah. We're going to be doing parametrics and polars soon. Polars. So the polar coordinate plane is kind of cool. It measures in radii and angles. So if you think about like latitude and longitude lines and like what a radar map looks like for like say a pilot or something, that's actually a polar coordinate system. So that's kind of cool. We're going to do a little bit of that in a bit. Not on this test. Sorry, microphone. I just coughed into the microphone.
Well, at least they can't get sick.
That's true. You're protected at home. Hyperbolas. No. Alright. I would like you to look at worksheet 11 still. Look at number 5. I am terrified about what you guys are going to do for number 5. I'm sorry. That's rude, but man, I'm really... Okay. Let's get a picture for where we're trying to go, guys. This x squared on a parabola, I don't want it to look like this. I want it to look like this. So what I'm going to write down is like, it's like my vision board. This is what I want. Right? So go ahead, make it look like that. So think about what we have to do. All the x's, keep them all together on one side of the equation. Everything that's not an x, take a hike.
Yeah.
So what if I added this 135 over, called this y plus 135, and then I heard take out a 2. Can I 1 up that? How about I take out a negative 2? So that gives us x squared. This will become a plus 16 x. We're going to complete the square. And then I'm going to need to balance everything out. All right. Guys, what goes in this blank? It is a 64. What goes in this blank?
Negative 128.
Nice. Why is it negative 128?
Because you have to multiply that.
Yes. This stinking 64 is not even a 64. It's a negative 128. There you go. All right. So on the left side here, you just got to make that look as pretty as you can. So how about y plus 7? And on the right side here, leave the negative 2 in front and then write this in factored form. So x plus 8 squared. And this is where my dyslexic brain roars because I'm like, it's not right. Okay, first of all, it's backwards. See that? That bothers me a lot. Something else that bothers me is there's not supposed to be anything in front of the squared term.
So we have to divide by
I gotta either divide by negative 2 or multiply by negative 1/2. Yes. I'm gonna do both of those things. I'm gonna reverse it.
reverse the reverse.
Reverse. And I'm gonna multiply by that negative 1/2 that you just talked about. So now I just have, okay, I'm not gonna do this question. Now you just have x plus 8 squared equals negative 1/2 y plus 7. Now this particular question, all they wanted you to do was write the parabola. That's awesome. I'm going to take you one step further on the test though. It's going to say, then find the focus and directrix. This is a bit of bad news for you. this negative 1/2 right here, what does that represent? It represents 4p. So what is p? Yes. Now, Daniel's very savvy with fractions. Some of us aren't so savvy with fractions. Remember, dividing by 4 is the same thing as multiplying by 1/4. That's why he's getting the negative 1/8. Okay? So if I want the focus point, and I want the directrix for this type of a parabola, which is I already lost track of it, a vertical parabola, the focus, the ordered pair formula for focus is h, comma, k plus p, and the directrix is y equals k minus p. So this is where kids start to freak out, and they're like, it's ugly. Yeah, I know. I'm literally going to take any answer you give me as long as it's equivalent, okay? I never actually found the vertex. Can someone help me with that? The vertex was at -8, -7, so that would be -8, comma, -7 plus, what's p again? Yuck. No, do something with that. So like -8, comma, you can call it -7 1/8. I'm okay with that. You can call it -7.125. You could call it -57/8. I don't know why you would, but you could. The point is, I'd rather you not do mental math with fractions that are negative and stuff. Can you? Yeah, -7 plus 1/8 is -7 1/8. So 57/8 would be the improper fraction. 56 plus 1. Remember that guy? It's okay. You could also math enter on your calculator. The point is, I don't want you to like get it wrong because you can't add fractions to integers. Directrix though, watch the double negatives here, guys. This one gets screwed up quite a bit by children. Y equals k minus a -1/8. Again, this is not a moment for mental math. I hate to say that, but it's true. Okay. So this is y equals, and this is kids start to do mental math, and I'm like, stop. Daniel's doing mental math right now. I can see it. Oh, okay. I'm just spacing out. That's okay. That's okay. It's -6 7/8, or you can say -6 point whatever that comes out to, was a 625 or something.
6, 7.
Yeah. Okay. Yeah. That's more, it's one of those.
875.
875. Thank you. And the improper fraction is also okay. I just don't overthink it, and definitely don't do mental math. That's my advice to you. 5 would have been 65. What? Well, and the reason I wanted to do that question in particular, it's like that on the test. The p-value is funky. So can we, here's what I would say. Decimals, best answer. Because the whole point of this is to graph it. Like, do you think I want to graph 57/8? No. Like, the first thing I'm going to do is reach for my calculator and try to figure out what decimal that is. So
because I've been told my whole life I can't do decimals.
Well,
and then,
with certain exceptions
now
in math,
once I get
right?
good at fractions, no, I can't do.
Well,
I could, but
you can. You can. It's just, the point is, if I'm graphing, first of all, you're lucky if I'm even in the right box on the coordinate plane, much less whether it's 0.625 or 0.675. Like, forget it. You're lucky if I'm even in the right area. All right, now I kind of wished I wrote a lot smaller. Apparently I did not. I'm going to clone this page because I want to look at number 6.
Number 6. I drew over number 6.
I know. You can just watch me do number 6 if you don't have room. I'm not going to do 7. I can tell you that for sure.
How about number 8?
I don't know what 8 is. Probably not. All right, so number 6, they want you to write the equation. I am a big believer in starting with a sketch, and that's something coming from me, because my sketches are crappy. So again, Daniel, look, they gave me a fraction, and what's the first thing I'm going to do is change that to a decimal, because I don't know what that is. It's 8.75, right? It's 3/4.
I don't know. I don't feel like mathing.
I don't feel like mathing. 8.75, okay. Because I'm not going to graph 35/4 as a point component. That's stupid. All right, so anywho, I'm graphing this. It's a really ugly graph, but I'm doing it. And we've got a vertex of this parabola at 9, -5. Cool, cool. And then you've got a focus point at, I don't know about that, 8.75, -5. I don't think it's vertical at all, child. So that's why it's important to sketch it. Because if you're going off like, oh, it's vertical, use the wrong formula, you're in trouble. So it's definitely horizontal. Can you tell me something else about this? It's left, so the p-value is going to be something negative. I don't think we actually have to do any math. Other than, I guess, subtraction. Other than subtraction, right? This is 9, and this is 8.75. And the distance from here to here is p. And you guys told me it's negative because it's going levsies. Now, if you used the formula where you like said, oh, this is h plus p equals this, you're still going to come up with p equals negative 0.25. But wasn't it so much easier just to be like, it's a distance of 0.25, I'm done. Trust me, it's easier, okay? Conceptualizing is much easier. Now that we've decided we have a horizontal parabola, make sure you have the right formula you're working with. The formula is y minus k squared equals 4p times x minus h. So now we just plug these in everything we know. There's h and k. You just found p. Here goes. Y minus, careful, who's k? -5. So this becomes y plus 5. Most common mistake I see on these kids are sticking the h and k in the wrong spot. Very frustrating. All right, 4 times p. Well, 4 times -1/4 is going to be a -1. Very good. And then x minus h would be x minus 9. Ta-da! That was it. You already had the vertex. You just had to figure out p. So I think parabolas in particular, man, conceptualizing is the way to go. Like, those formulas stink, man. All right, hyperbolas. This is an extra question. I believe it's on your review, and it's very much like the question that's on your test, where, again, I don't even know what kind of hyperbola I have, so I'm going to sketch it. Apparently I'm going to sketch it very poorly. So -5, -6, I'm going to pretend is right here. That's a vertex. And then -5, -12 is right here. So I don't know why mine are so large, but here you go. We got this. So now you tell me, what formula am I looking at? For hyperbolas that look like this.
Y minus second.
Okay, so y minus k squared over a squared minus x minus h squared over b squared equals 1. And because I'm doing this in pencil, because I'm not a crazy person, I'm going to go through and just replace things as I find them. And I think you can go ahead and find h and k right now, because it would be the center. So this ordered pair, I didn't actually write anything down. This is -5, -6. This guy is -5, -12. So the center, clearly it's at -5, but the center of -6 and -12, that's as simple as a midpoint question, right? It's -9. Y'all, you just found h and k. So I carefully put them in the right spots, because that's the issue that some kids have. So h being -9 means this, k being -9 means this is y plus 9. And then h is -5, so x plus 5. Okay, the asymptote equation. This slope, if you look on your formula card, that slope is very clearly a ratio of what over what? It is b over a. B over a. You got to make sure you look at the right one, but it is for a vertical parabola. It's b over a. Are you looking at the second one, Taylor? The vertical, I said the wrong thing. The vertical hyperbola? No. Oh, it is a over b. Gosh be golly. You were so convincing. Like I said, it's a over b. I'm so sorry, Taylor. Like I said. And I was about to fix this, because look at what happens. Now, I'm just going to tell you, on your test, this is it. There's no reduction. I'm not being tricky. We're like, ooh, a is really a 6 and b is a 26. Like, no, I didn't do that. Like, if it looks like a 3, it's a 3. Let me show you how I know this. A is the distance from the center to one of your vertices. Yeah, that's a distance of 3. So check. That's how I verified that there's no weird reduction going on. So, like Taylor told me, A is 3 and B is 13, so plug her in. A squared would be a 9. And B squared would be a 169, and we're done, because they just wanted the equation.
You have on the test you have stuff where it says vertices, XYZ, blah blah blah, asymptotes, y equals something like that.
Yeah.
So I can just flip.
Yes, but don't pull an Abruzzo where you get A over B, B over A confused, because that'd be bad.
Wait,
So like on the vertical one, the slope is A over B. On the horizontal hyperbola, it's B over A.
so if it was just now it'd be 13 over 33, and then we put the 13 over on the other side.
Yeah, just make sure you're on the right formula. And I promise you the one on the test, there's 0 reduction on it. You don't have to be like, oh, she's trying to trick me. Because there was one on your homework where like B over A was like 4 over 2, and it reduced to a 2. But that doesn't mean A was 2. It was 4 over 2. So that's not the way on your test. Okay. I think we need to look at that, guy. This is worksheet 12. And we got 5 minutes to do it. All right, here goes. Y'all, we got to complete the square. And I think these are the hardest ones. So, completing the square, taking the positive one first. I see that there's a factor of 9. Please take the 9 out of that. And you have an x squared. Now it's a plus 2x plus blank. For the y's, you want to complete the square, and you do have to factor out the negative 1, because that's now going to be part of the formula. So that changes this to a y squared plus 2y plus blank. That 1 needs to take a hike, because I'd like it out of there. And then we're going to balance. And this is where I got to be careful when I balance. All right, I know this blank is a 1. 2 cut in half squared is 1. But what really is that? It's really a 9. And then this guy, I know that's a 1, but what really is that? There we go, that looks better. So keep the 9 in front. Write it as factor of x plus 1 squared. Keep the negative in front, or you can even call it negative 1 if you want. And then write that as a factor of y plus 1 squared. And if you add up all those pieces over there, you got a 9. One more step to get the equation.
Divide by 9.
Everything is divided by 9. And we want to leave these with denominators, and we want to reduce. So this fraction becomes x plus 1 squared over 1. And then this fraction is a minus in front of it, but then it's y plus 1 squared over 9. And it equals 1. So this is fantastic. You guys have this lovely, what's going to be a horizontal hyperbola. I'm going to ask you to find all that crap, and I'm going to ask you to graph it. And if you remember our work from the last couple days, I'm going to humor my teacher by finding everything with the formulas, and then when I graph it, I don't even look at those things, but I do kind of match them up. So I'm going to ask you for these things in this order. I'm going to say, where is your center? Where are your vertices? I'm going to ask you for foci. And I'm going to ask you for the equation for the asymptotes. All of this can come straight off the formula sheet. So center we know is at HK, which is -1, -1. Bless ya. Vertices for this type of hyperbola, this is the horizontal hyperbola, the vertices are at h plus and minus a comma k. But tell me if I have the wrong formula, because that'd be bad. So for us, that would be -1 plus and minus. Wah, wah, I never found a. This is a squared, right? So a is 1.
I thought a squared was I thought it was the bigger.
No, not for hyperbolas. The positive one is a squared. So I better do this real quick. Who's b?
3.
And then might as well find c while we're at it. C is the square root of a squared plus b squared. So that would be the square root of 10. Just leave it like that. All right, here goes. So back to the vertices. -1 plus and minus 1, comma, -1. But pre-calc, you're better than this. -1 plus 1 is 0, -1. And then you got what? -2, -1? I'm sure that's right, but I'm going to find out in a minute. The foci are located at h plus and minus c, comma k, for this type of hyperbola. So we've got -1 plus and minus the square root of 10, comma, -1. And I am not going to split that up, because who cares? That's ugly. For this type of hyperbola, the formula is y minus k equals plus and minus b over a times x minus h. Those y minus k, x minus h pieces come straight out of the formula. So for us, that would be, where to go? Y plus 1, and then plus or minus b over a would be, b over a would be 3 over 1, so 3. Do I have the wrong formula again? I hope not. Okay. And then x minus h was the x plus 1. Don't put the squared with it though, guys. It's a line, so no squares. And then here's where, like, I really just did that to humor my teacher because I'm about to graph it and not even look at any of that. Oh, I really need to zoom in though. Dang it. Okay. Guys, I don't have time for this. Remember what we do is we plot the center and then we go horizontally 1 unit. We go vertically 3 units in both directions. We make that auxiliary rectangle. And then asymptotes. Life is good. All right, good luck, everybody.